class, we will discuss about a root file system, that is a creation of a root file system. So for creating the root file system, your Linux or a bootloader, for the bootloader, we have used a U-boot. For the Linux, we have used a kernel source code. Similarly, for the root file system, we'll use a source code which is given by a BusyBox. So this BusyBox, what it will do is, this is a software utility which provides the root file system source code that we can compile and build it so that we will get a complete root file system. So in the Linux, the root file system, as we discussed, it gives you a basic directories which is used for saving your application, saving your boot related files, and it is also helpful for recovery of some files, and it also helpful for including libraries and the details regarding your devices, that is a peripheral devices, into the root file system. Based upon these application, your root file system will have a directories like a boot, mount, home, user, etc, etc. So first thing what we are going to do here is, we are supposed to download a Linux kernel. Since in the previous laboratory also we have done it, but for this BusyBox with a try and error method, we have got this Linux source code, which is very much helpful for building a root file system. So we have to download the Linux 4.4.1 version of the kernel source code. Once it is done, you know how to extract it, and then you know uh, how to enter into the Linux folder. So one thing is, we are compiling and building the Linux kernel. Then we are compiling and building the root file system in a different folders. Then what we will do is, we will build a root file system by taking an image of the kernel, and we will launch it in the QEMU. So for that, if you are using the fresh OnWorks, you are supposed to install two packages. One is GCC ARM Linux GNU EABI, and the another one is a QEMU system. If you are using the previous OnWorks, then it works fine. Otherwise, if you are launching a new OnWorks, then you are supposed to install these two, but we have already used it with the previous experiments. Next thing is, first I am supposed to compile your Linux kernel for the board of VExpress Cortex A9. So we are not using a versatile PB, but we will be using VExpress Cortex A9 for our experiment. So for that, first we have to set up the type of architecture and type of cross compile. So the type of architecture we are using ARM. Why cross compile? Because upon x86 we are compiling for the ARM architecture. So the cross compile will be ARM Linux GNU EABI. This hyphen represents that the cross compile also uses all the tools which is present in the GNU EABI, like GCC, LD, AS, etc. Then we will do a make. So make, what it will do, it will search for the make file and it will compile it. The compile it for which type of device? It is for the VExpress, and it will write the configuration to a .config file for the particular configuration, that is VExpress. Once it is done, then we'll go for the make Z image. That means we are going to compile it again and create the Z image, and the required modules where you can save your libraries, that also need to be created. That we are going to do it with respect to make modules. Once it is done, we will going to create a DTBS. So can somebody tell me what do you mean by DTBS? I have repeated in the class. Yes. So what is DTBS?
It is a directory tree binary, I think.
No.
Some tree it is. I'm not
Okay,
sure.
somewhat correct. Somewhat correct. Good try, Ram Prakash. Any other results or any other answers? Okay, it's a device tree block. Usually during the Linux boot process, a device tree blob, that is a DTB file, is loaded into the memory by a bootloaders like your U-boot, and a pointer will be passed to the kernel of this tree. Okay. So that DTB will also be created. I will show you where that DTB files will be created during the experiment. So once it is done, next we will compile it so here you have to exit from the Linux directory, then you are supposed to download the BusyBox. So where you will download the BusyBox, the path I have given it, the version should be 1.25.1 only. Next, you have to extract this BusyBox, and then you have to configure it. Here, no need to give what type of architecture. You just need to say that it is for the Linux operating system. So in the cross compile, I will say ARM Linux GNU ABI i5 as a toolchain. Then we will install. So once it has been installed, you will get a underscore installed folder or a directory which contains all your root file system directories like your mount, boot, lib, user, etc, etc. So here one way we have compiled and created the Z image, and one way we have created the root file system. Then we are supposed to combine these two. How to do that? So you have to exit from the BusyBox, and better you enter into the document directory, or you can even work in the home directory by creating one directory, but it should be a sudo. That means it should have a root access. So here for the better option, I will go for the document directory. In that, I will create sudo make dir rootfs. That means I am creating a folder or a directory called rootfs which have an root permissions. Next, I will create a lib directory. Once it is done, then I will go and copy. I will go to the BusyBox and I will copy underscore install into the rootfs directory. That means whatever this star represents, whatever the files and the directories which is present under the install, everything should be recursively copied to the root file system. Next, we are supposed to copy. Okay, we are supposed to copy all the libraries of ARM Linux GNU UABI to the rootfs lib. So it will be present in the user directory. Next, we have to create the 4 devices. How we can create the 4 devices? The first thing is we will create a directory called a rootfs /dev with a sudo, and then we will use a make node. That is, what do you mean by mk node. So it creates a special file, and it this file can be of the type blocks or can be of the type character. So here the C represent it is creating the character. There is a one more option is there. It can also create a blocks. So here it will be first one will be the major character, and the second option is the minor character. We also have an option for using P, which also creates a pipelines. That is, we can also create a first in first out files using this MK node. So here I am going to create a 4 devices which will be present in the dev, that is TTY1, 2, 3, 4, which is of the type characters having the major 4 and the minor 1. Okay, so there is a one more command called ls -l /dev. I will show it during the execution of the commands. Next, once it is done, next you have to create a dummy image called A9 root FS. This is a root file system image which we are going to attach with a kernel. Next, we have to convert this to the format of ext3, that is a file system. So once it is done, then you have to copy all the things like dev, root fs, and which is present, that is a lib, everything into one folder called temp fs. So for that we are going to create a one directory called temp fs, and then we are mounting this image whatever we have created with respect to the loop. So, and then we have to copy all the files which is present in root fs, that is a star represent all the files, all the directories to the temp fs, and then we are going to unmount it. Next, once it is done, then we have to launch the board. Since the board is not present, I'm using the QMove. With the QMove, the machine I'm using is a VExpress A9 with a memory block 512 megabits, and the DTB. As I told you, the DTB also supposed to attach. This extra folder is, you should go to the Linux folder. Okay, you should go to the Linux folder and see where is the Z images. That path you are supposed to give it here. And then for not Z image, DTB file. So that also I will tell you where that exists. Next, you are supposed to attach the kernel. Again, you have to go for that Linux folder, and then you have to search where is a Z image. Usually, these two will be present in the architecture ARM boot file directory. Then first I will say that I don't want any graphic, and then append root is equal to dev mmc blk0 read and write console ttyama0, that is your monitor, and you are supposed to attach your root file system that is present in a9 rootfs.ext3. Okay, so this is what you are supposed to do it. We will do that now. Okay, so okay, I will just create a one directory mkdir usn a section. Next, copy busy usn a section. Not this. Next, copy my Linux source code. Linux okay. So both I'm going to copy to the USN folder. So once it is done, I'll go into the USN folder, just give ls, so you have BusyBox and Linux. So in this, first I will extract my Linux folder. Okay. Next I will extract even BusyBox. Okay, I will go for the Linux folder. So what is the command? It says first thing is export architecture is equal to ARM. Export is equal to ARM. Export cross compile is equal to ARM hyphen Linux hyphen. So once it is done, then make vexpress defconfig. I'll just check whether it is correct or not. Yeah. Next I'll do make z image hyphen j8. It takes some time. Until that, I'll just give some. I'll just uh, put some questions for you. Can you tell me what all the root file systems are being created, or what all the directories are being created under the root file system? Yes, Vedaraj. You can put it even in the chat box. Vedaraj, are you here?
Yes, ma'am.
Yes, what all the directories are being created under root file system? Anyone else?
User,
Yes,
share, MNT, etc.
correct,
Libraries.
correct. So these are all the directories will be created under the root file system. Any other directories are missing here?
Bin.
Correct,
Opt.
correct. Okay.
Even TMP,
So,
I guess. Yeah, it's already said. Okay.
pardon? TMP. Yes, it is
TMP.
already present. Yes. So next, I just told you in during the experiment, like MK Node. MK Node creates a special files for the devices. So we'll see whether we have already have those type of devices by using command called. Okay, I'll just zoom in. Which usually present in the dev. Okay. You can see that the files are already being created. So these are all the files which is created under the there. Okay, I will just yeah.
You want me to add some part over here, explain the content
Yes,
of
sir.
slash? Okay, if you
Yes,
see that in the slash dev directory, unlike in the files, the first character is either C or B along with the D. Right? Some of them are C, some of them are B. C stands for your character devices, where the input output with the device is character by character. There is no buffering. If there's a B, there may be some devices with B. B is a buffer. Okay, it's a block device. It's a buffer. That means the data transfer goes in blocks. Only after 512 bytes have been into the buffer, it will be written onto the. It will be sent to the device. For example, the hard disk. But whereas the mouse, it is a character by character, so it will be C. Your CRT is also C. That is the first thing over there. Then instead of the size, there is something called as a some number comma some other number, right? The first number they call it as a in this case 10 is the major number. There's a group of devices. For example, you have 2 3 hard drives or a partition. You have partitioned the hard drive. All of them will have the same major number, so that the kind of the I/O for the device is the same. The minor number tells which partition hard disk partition it is. So that is how the slight difference with the files in the slash dev directory and your regular files. Yeah. Any questions at that part?
No, sir.
Thank you. Thank you, sir. Okay, still it is running.
Can you show that steps? I just wanted to add some more part over there.
Yes, sir. Yes, sir.
Steps 4.4.
Yes, sir.
Okay, we use something called as a DD. Why not CP? DD stands for disk dump. So what it
Desktop.
does is you can specify the track in which the character track you can access the file track by track with the DD, but with the file it is not possible. If you want your operating system, your OS should start from track 0 sector 0 in the hard disk. If you use the CP, that is not possible. If I use the DD, it I can have that file starting from a specified track. So that's why we do the DD over there, and we create that .ext3 file. And I want to add the information into that one. So for that we use the mount. Okay. So once we say mount, that uh, file system becomes part of our file system. Now I can do the copy and other things. I cannot simply copy into the ext3 file at the once I do the DD. Once I mount it, it is visible for us. So I'll load it. Effectively, what happens is when you say the last but one line cp minus r, you are copying the contents of your root file system in the track 0 sect 0 of your .ext3 file. So when you load it onto the operating system, it starts executing from that location. That is how. That's why we use the dd mount and copy. Briefly about that part. Be happy to take questions.
No questions? Okay. We'll wait for a few more minutes, let it get completed.
The CC there says it is compiling that one. Then subsequently there is LD. It links those parts. While that is going on, feel free to ask questions.
So what you can do is in the onworks, once you have done that is compiling and build your Linux, save it in the Google Drive, and then you open again and build your root file system and save it in your Google Drive, so that even though the network fails, the important part will be saved that as an image in your Google Drive of your onworks.
Our experience is onwards is faster during the morning time. And subsequently afternoon onwards it slows down like anything. Not sure whether it is the same with everybody, but that's what I thought so.
It's almost done. The recordings and the um, PDF will be uploaded in a Moodle by today. So you can use that. You can see once again today, and then you can uh, write down everything on the paper so that the on works, if you are using tab, then it may get logged out. So it's better you note everything, and then you start working tomorrow, because onworks will get logged out if you are using tab or if you are using some other files or if you have opened other applications. Yeah. So the Z image is ready. You can see that the Z image is architecture ARM board image. So you should know the path of this. So after the Linux architecture ARM board Z image. So once it is done, then we will do modules. That is, we are creating a modules I8, J8. So then we'll create my DTBS. I'll just check the command properly once. DTBS. Once it is done, we'll just check whether the Z image is present or not. Okay, in the architecture, that is CD architecture ARM boot ls, we can see that the Z image has been created. And then if I go to DTS, we can see that for the vexpress v2 sorry a9, it is a9, yeah, vexpress v2p a9 dtb file has been created. So you should save this path for giving it to the queue. So this is one thing. And then next we'll move on to compiling and building a BusyBox. Clear. So I have already downloaded the BusyBox, and then I have extracted the BusyBox at the very first steps. So then what I have to do with the BusyBox is I have to make a def config, and then the cross compile is equal to ARM Linux GNU EABI. So I will do that. Make def config. So it creates a configuration file which contains the configuration of vExpress. Next command is make cross compile. So make cross is equal to ARM Linux GNU EABI hyphen, very important. So you have a next class at 12:40, but I have requested Rajaram sir to join for 10 minutes late.
Ma'am, next period we have communication networks.
Communication networks. Okay, I'll just inform.
Okay.
It will not take much time like the Linux. Yeah, so it's got completed. Next, we will install that. So to create a installation folder, you can see that it's installing all the directories like user, sbin, bin, etc. Okay. Now, if you want, you can go for this underscore install and you can see whether it has created the directories or not. You can see that lib sbin user, that is a basic directories, has been created. Next, this is done. I just wanted, okay, I will just come out from this. Okay. So right now I am in the home directory. Okay. As I told you, you have to create the root file system directory in the documents. Already the things are being done. It is for the previous or it is for the other section. So I will delete these files. To delete these files, as I have created with a sudo, you have to delete with a sudo only. That is rm-rf a9
You can show with ls minus l so that it has a root permission. They can see that.
Yes, sir. Yes. ls minus l. See, this A9, it has a root permission. Root fs has a root permission, and this is also having a root permission. You can see over here. Okay. So next, I will just delete an RF. Sorry, RF. Here, root permission. RF E9. Yes. Okay, see, everything is clear. Now I have already saved the commands because it's a little bit difficult to copy from there and here. So I will just go with that commands. So first thing is I have to create root file system. Next I will create a lib. Next I have to I have to copy. Okay, I will just zoom it. Okay, it's okay. I will be sure. So the next thing is I have to copy the underscore install file to the root fs. So what I will do, I will go for the BusyBox, listen, BusyBox ls. So there is an install, correct? So I will just copy underscore install all the directories, and then it is recursively. So -r /home /username, and then documents. So we have USN and not USN, documents, and then in that where I'm supposed to copy, I'm supposed to copy to root file system. So I will copy to root file system. Since permission denied, if you are getting, you use sudo. That's it. That's it. So now it's clear. Next, I will go back to my root file system directory, or just a documents directory. So I have a root file system. So then what I have to do is, according to your instruction, I should, okay, this has been done. Then I have to copy this library files into the root file system lib. So I will do that. Copy capital P user Linux lib all the files to where? To root file system lib. So root file system, sorry, root file system. Again, it is saying permission denied, so I'll give sudo. So don't panic when you get the permission denied error, just give sudo over there. So next, what is our next instruction? So the next instruction is sudo make dir -p rootfs/dev. So you are supposed to create dev directory. So I will be creating sudo mkdir rootfs dev. So it has been created. Next, I'm using mknode to create the files called tty1, tty2, tty3, and tty4. So 4 devices I'm going to create. 2, 3, 4. 4. So once it is done, then you are supposed to create a file with an extension ext3, that is a root file system for vertex A9 of a file system ext3 using the command dd. IF is an input, OF is an output, BS represents bits per second. So this creates a very empty image. Okay, it is used to create an empty image. And then I'll convert that. Even though I have created, it is not ext3 file format. I'm supposed to convert it. So I have converted. Then what I will do, I'll create a temp file system. So I have created temp file system. Then I have to mount this temp file system to the image. See here, there is a nothing over here. Okay. Once I have mounted, a file system has been mounted and you can see it over here. See, you can see that a mount file system has been created. Next, I will copy the entire files of which is present in the root file system, and then I will do unmount. Umount, that is an unmount of temporary file system. Okay, it's done. Now you can see that using A9 root file system, which contains all the folders of a root file system, has been attached, and now we are going to launch QMO. The last command, I'll just take copy. Okay, I'll pause it here. So here I have taken QMO system with a machine and with a memory 512 and -DTB. Here I have taken already built DTB file. If you want, you can take that path also. Okay, since we have already done it, we'll take that path. So this is the path, that is usn underscore a Linux. So I will just add that path. So here usn underscore Linux 4.4.1 architecture ARM board DTS vexpress v2p ca9 DTB file, and the same like for the kernel image also, it is usn Linux 4.4.1 and it's a Z image. I'll go with a no graphic, then I will append the roots and the console and then your root file system. Okay, so once it is done, what you will get, you have to press enter to activate this console. That means the root file system has, the kernel has been booted up. If you want to see the root file system, you have to give enter. Now you can see that it is something like your terminal. So here, so how you can see like your terminal, similar way you will get the terminal over here. I will just want to check whether the root file system has been created or not by giving ls. You can see that the basic directories are being created, that is a bin, dev, lib, sbin user, etc., which is usually found. Okay, I'll just pause for a moment. You can see the directories, which is usually found when you go for the root of your root file system. That is a bin, lost plus found, sbin, user, etc. That you are ready with respect to a root file system. Any doubts? Any doubts? Okay. Thank you, guys. We'll meet you in the tomorrow's laboratory. So make a note
Uh,
of all the instructions. Yes.
Excuse me, ma'am.
Yes.
I've actually made a little bit of a solution for like the problems that we have. You're running different versions of GCC and all of that, and like
Yeah.
that we are forced to use OnWorks.
Huh?
So what I've done is I've actually made a Docker image that contains
Yeah.
the things that we need.
Hmm.
So like it's much better than OnWorks, and I mean it's faster, and then all the problems of sessions timing out and people losing data will not be there.
Okay.
So
Okay.
I mean
Can
I'll
you
just
share the
yes, ma'am.
Docker images?
I've
Okay. You
put
can
the
share
link in
the
the
Docker
chat.
image. Yeah, not a link. It's better you put it in my Gmail, so I will add it in the Moodle so everybody can access to that Docker image. And
Uh,
also add the procedure how to use the Docker image for the students.
okay, ma'am. So
Yeah.
basically they can download it themselves. So it's all contained in the link. Yeah, any other
Hmm.
instructions I'll probably add and then share it. So it's all self-contained. So there are even
Uh,
instructions.
it is actually a very good option of using Dockers uh, for your experiments other than the OnWorks. And I think the students even they can follow this procedure also.
So yeah,
Any other
that's
doubts?
about it.
Thank
So
you, Ram Prakash. Thank you, Ram Prakash. A very good job. Any other doubts? You want to say something, Ram Prakash?
no, ma'am. I guess they can check that out if they have any more questions, or like if any I need to add any more instructions, they can just let me know. Then
Yeah, yeah. So
I
that
can.
also, you people can do that. You can copy this link, and in the next tomorrow I have a class at 11 o'clock, so that we will have a little bit 10 minutes, so that 10 minutes time for this, so that the Ram Prakash can dis can give the instructions of how to use it for the other students also. Is that okay, Ram Prakash?
Yes, ma'am.
Okay. Thank you. Thank you all. Meet you in the tomorrow's class. Sir, you want to add something?
No, that's okay.
Yes, sir.
Let them go
Thank
to
you.
the next class.
Yes, sir. Thank you, sir.